Hello dear friends, it's Tamko again, and today we're talking about the ADAT audio protocol. Let's get straight to the point. The ADAT protocol is used to transmit audio signals in a digital format between devices. For example, between two audio interfaces, between a groove box and an audio interface, or even between two groove boxes. Basically, between any sound source with an ADAT output and the receiving device with an ADAT input. The beauty of the ADAT protocol is that because we're transmitting sound digitally via optics rather than through standard analog audio cables, we can pack up to 8 independent monochannels into a single fiber optic cord. Let me repeat that again. 8 separate channels inside one optical cable. If we were doing this with analog connections, we'd need 8 mono cables or 4 stereo cables. So when do we actually need this? Let me give you a few real-world examples. Example 1. Let's say your audio interface only has 2 inputs and they are both occupied. But your audio interface has an ADAT port. You can use a fiber optic cable to connect another audio interface, a groove box, a mixer, or a dedicated ADAT converter, and route up to 8 additional monochannels into your main interface through that single ADAT port. As a result, a standard interface like the Apollo 20X suddenly turns from a 2-channel device into a 10-channel powerhouse. Example 2. Imagine you have 2 separate rooms. In one room, there is a live performance. In the other, a control room where you're sending the live audio to a stream via OBS. In theory, and I've actually done this in practice, you can mix the live sound in the performance room so the audience hears it perfectly according to the room's acoustics. Then, using just one fiber optic cable via ADAT, you can send a completely clean, unprocessed copy of all those individual channels, like different vocal mix or the backing track, straight to the control room. There, you can apply entirely different studio quality effects and broadcast a pristine mix to your stream. Example 3. Devices like the Ableton Push 3. The Push only has 2 mono inputs and neither has phantom power. However, it does have an ADAT input. If you have an audio interface, mixer or converter with an ADAT output, you can fit 8 more channels into the Push 3, just like in the first example. This is exactly how you can record condenser microphones or multiple synthesizers directly into the Push. And the last one, still on the Push 3, but in reverse. It features not only an ADAT input, but also an ADAT output. This means you can send up to 8 channels of audio from the Push to an audio interface or a live mixing console via a single optical cable with absolutely zero loss in quality or interference. Or if you want to go totally crazy, you could even wire 2 Push units together. Now that we've covered the examples, let's dive into a bit of theory. We need to understand the fundamental difference between a physical medium standard and data transmission protocol. The physical medium standard describes the actual hardware, the types of cables we use like copper wire or fiber optic, and the connectors at the ends like the 3.5mm TRS, mini jack or RCA. Here is the catch. You can transmit completely different types of signals through the exact same copper cable with a jack connector. You can send a standard analog audio signal, or you can send MIDI over TRS. Look at the Push 3, for example. Its MIDI port isn't the old-school 5-pin DIN connector. It's a mini jack, and it's absolutely not an audio input. How is it possible that we can transmit totally different things, analog audio 1 minute, digital MIDI the next, over the exact same type of cable? This works because the transmission protocol is entirely separate from physical medium. A protocol is the language of communication between devices. It dictates exactly how information is encoded, how it's synchronized, and how the receiving end interprets it. For example, there is the MIDI protocol, the Dante network audio protocol, heavily used in live concerts, and of course our topic today, the ADAT protocol, specifically known as ADAT light pipe. Imagine being a kid again. You take 2 plastic cups, stretch a string between them, your friend puts one cup to the ear and you speak into the other. In this scenario, the cups and the string system is a physical medium, but the language you choose to speak to your friend over that physical medium, that's the protocol. If you speak using your voice in English, that's one protocol. If you still use your voice but squeak out Morse code into the cup, that's a second protocol. If you tap binary code on the bottom of the cup, that's a third protocol. The same goes for ADAT. As a data transmission protocol, it defines the algorithm for how we format and transmit already digitized sound and how it's decoded on the other end. In the simplest term, the physical medium dictates which cable you buy at the store and what it's made of, while the transmission protocol is the secret language the connected devices use to talk to each other over that cable. If that hasn't fully clicked yet, let me emphasize this one more time. Sound sent via ADAT is transmitted in a digital format with all the properties that come with it, namely sample rate and bit depth. It's not an analog signal, it's entirely digitized, just like the MP3 and WAV files on your computer compared to a vinyl record. The process of digital transmission, the optical cable is practically immune to electromagnetism interference, EMI. You never have to worry about ground loops or electrical hums. The con? It's physically fragile. Don't bend it sharply or the glass plastic fiber inside will snap and it will simply stop working. Why did I just spend so much time explaining the difference between physical hardware and protocols? Because I want you to understand that there is no such thing as an ADAT cable. ADAT light pipe is the protocol, the algorithm sending ones and zeros through the light. The actual physical hardware, the optical interface and the cable you need to buy is called, plot twist, Toslink. When you combine the protocol and the medium together, the ADAT light pipe protocol flowing through a Toslink cable and connector, you get the complete ADAT interface, which officially closes the book on this terminology. I want to make your life easier so you don't go hunting for a non-existing ADAT cable and pay triple the price. Literally any Toslink cable from an electronics store, even one meant for a home theater setup, will work perfectly. And, unlike analog cables, there is no audiophile quality debate here. The cable is just flashing a light on and off to send ones and zeros. Discrete digital values don't have varying degrees of quality. They either arrive or they don't. Just like a mini jack cable can carry either audio or MIDI, a Toslink cable can carry either the ADAT protocol or a different digital audio protocol called PDIF, which we aren't covering today. These are two entirely different protocols sharing the same cable, and they are not compatible with each other. If the transmitting device is sending ADAT, the receiving device must be expecting ADAT. For instance, the Apollo Twin supports both protocols, ADAT and PDIF, and you can choose which one to use in the Apollo console settings. But the Push 3 only supports ADAT. So, if your receiving interface is set to PDIF and your push is sending ADAT, which is its only option, the setup won't work even if the cable is plugged in perfectly. Pay close attention to your settings. To summarize the theory, you buy a fiber-optic Toslink cable and you use it to transmit encoded digital audio using the ADAT protocol. Now that we've covered the theory, here are 3 vital rules to remember before you start plugging things in. Rule 1. Sound via an optical cable only travels in one direction. You can actually see this. An ADAT output will glow with a red light, while an ADAT input stays dark because it's an optical receiver, not a transmitter. The light flows through the optical cable like water through a pipe, and you can see it shining out of the other end of the cable. Because of this, if you want two-way back and forth communication, you must buy 2 Toslink cables, one to send, one to receive. However, if you only need to send the signal to somewhere, you only need one cable. For example, sending audio from the Push 3 to the Apollo Twin X is a one-way street, one cable. But if you want to route process channels back from the Apollo into the Push, you'll need a second cable. But actually, the Apollo Twin X doesn't have an ADAT output, so this connection is not possible. Rule 2. Not all devices have both an ADAT input and an ADAT output. The Push 3 has both. The Apollo Twin X, however, only has an input. That means I can send sound from the Push to the Apollo, but I cannot send sound from the Apollo back to the Push. Higher-end Apollo models like the Apollo 8 or X4 have both in and out. My old favorite, the RME Babyface, also had both. Pay attention and always check the pictures of the back panels before you buy an audio interface. Rule 3. For the communication between devices to work properly, both the sending and receiving devices must be set to the exact same sample rate. For example, both at 44.1 kHz or both at 48 kHz. Furthermore, one device must be set as the clock master and the other as the slave to keep the digital signals perfectly synced. If you don't match the sample rates and sync the clock, you will get the exact same nasty audio artifacts as when you drag a 44.1 kHz file into a 48 kHz DAW project without converting it, a glitchy, clicking, strange mess. Don't make the mistake. And just like that, our video has come to an end. I don't think we need a grand summary here. By this point, everything should be crystal clear. If you found this video helpful and want to support me, please go to listen to my music on all streaming platforms. Just search for Tamko, Tamko. If you have the means, feel free to send a donation or simply help promote this video and the channel by liking and sharing. See you in the next videos.